Ladies and gentlemen, please welcome the CEO and founder of Datera, Mr. Marc Fleischmann.
I'm excited to welcome you today to our event to talk about a big step forward in how data clouds will be built. The digital world is changing faster than ever and is creating an unprecedented amount of opportunity to create new value. The explosion of data is also posing daunting challenges to all of those who cannot intelligently access this data. But what if you had the freedom on creating business value rather than spending all the time to keep up with your ever-changing infrastructure? Welcome to the data era. Welcome to Datera. In the data era, an incredible amount of interactions of billions of devices, millions of users and applications is generating an unprecedented amount of data. 150 million email messages, 21 million messages on WhatsApp, 3 million YouTube videos, 2.4 million Google searches, and 1 million new containers created by Google every minute. All of them expect interactive service. All of them expect a cloud-like experience. All of them expect a massive amount at their proverbial fingertips. With that added complexity, scale, and interactivity, services that just a few years were unimaginable are now driving entirely new demands on data. This immense amount of data, combined with the added complexities of billions of mobile devices, IoT, security, and stringent real-time processing needs, is challenging traditional IT. A few companies like Google, Amazon, and Microsoft Azure have actually mastered these challenges. They have the significant engineering resources to build the infrastructure of the data era. Their immense success is now challenging the existing enterprise. And where does that leave the rest of us? It leaves us at the information age equivalent of the industrial age. It leaves us with rigid, handcrafted silos that are dedicated to specific applications. Therefore, it leaves us with slow deployment, it leaves us with limited scale, and it leaves us with immense complexity. In essence, it leaves us with an obsolete model at every single stage of the value creation chain. It leaves us with an obsolete model for purchasing, for planning, for deployment, for operations, and specifically for economics. The promise of the cloud is to deliver an entirely new quality of infrastructure experience at an entirely new scale. But we need to bring our existing applications with us on that ride. We need to actually do this for any application, at any scale, and in any framework. This is a real challenge because we're stuck between the emerging world of agile development, digital processes, and unlimited scalability, and at the same time, the legacy world of rigid applications, fixed hardware and software architectures, and silo-based infrastructure. While everyone wants to move forward to the new world, most critical business applications are not there yet. The only way out of this dilemma is to build a common data plane, a common data infrastructure that accommodates all of those applications. This is what Datera does. So let me go back to the current problem, the challenges on traditional IT and how it's looking and how we can take it forward to this new world. Traditionally, when you have, for instance, performance applications, you build a specific environment for them to, for instance, map them on flash arrays, for deliver high performance. Or if you have, say, a capacity application, you would perhaps map it on a disk array, on a more traditional disk array to save cost, to have it very economical. Or if you have a mixed workload, you would match it to a hybrid array and get the corresponding price performance profile. How do we take that forward and actually bring it to the cloud? We do that by building a unified data infrastructure. We pool the resources, we pool every performance band in these arrays, and we deliver it in a cohesive way. We then map the policies, we map the requirements of the applications, the business intents of the applications on those performance bands by expressing them in policies. And lastly, we tie all of this together with a self-optimizing system that continuously balances between application needs and infrastructure capabilities. This is the promise of the cloud. That is the kind of data infrastructure that we're bringing to it. So to wrap this up, Datera builds automatic data infrastructure for all business needs, for all business requirements. We do this by learning your application needs and understanding your data center capabilities and bringing them both together. This allows you to run any application in any stack at any scale, which then provides game-changing performance and game-changing economics. Thank you very much. Now I'd like to welcome a guest who has a unique insight in how to build clouds. He is from Google and can give us specific perspective and his approach to unlock the power of data. Let's welcome Bogomil Balkansky. Bogomil, it's great to have you here. Thank you for coming. Let's talk a little bit about yourself. Maybe tell us a little bit about your background.
Well, Mark, like you and so many other people in the Valley, I'm also an émigré. I'm a first-generation American. I grew up in Bulgaria and came here for college and kind of never left.
So you came here and pretty soon you got involved in one of the biggest revolutions in the enterprise in about a decade. You joined VMware. That must have been an exciting time.
Yeah, I absolutely consider myself lucky that I got to participate in that first wave, I would call it, of cloud infrastructure that VMware created in the 2000s. I would say that this groundswell that we're seeing today, the transition towards cloud anything, be it software as a service applications, be it cloud infrastructures, really the genesis of that was the invention and the commercialization of the virtual machine by VMware. This was like the first instantiation of showing how IT provisioning and management can be done a lot more easily, a lot more faster, greater agility, if you transform hardware into software.
So you've really been in the center of what perhaps you might call now Cloud 1.0. Data centers became software-defined, so to speak, and it completely changed the paradigm.
Yes, it did completely change the paradigm. Now, the interesting thing is that that change didn't occur either quickly or easily.
And now we're seeing what the next tsunami, so to speak, Cloud 2.0, occasionally it's being called. It's all kind of based on containers, and they're really penetrating, proliferating in the enterprise, in the infrastructure at almost unprecedented speed. What's driving this? What is the challenge that people are trying to solve here?
I would say that the transition towards cloud in general really comes down to two things. One is simplification that allows you to do things a lot faster, or people usually call that agility. And the second thing, it's about a new business model, which is about pay as you go, pay for only what you consume. And this is a really drastic change in terms of how people think about the economics of infrastructure. But the speed with which containers have really emerged as like the new compute unit, I think is yet another proof point in that trend, or another step in that trend of simplifying things. The VM is stateful. It's a lot kind of heavier duty container than the container. Right. And so it's really kind of the next logical step in terms of making the infrastructure like lighter weight, easier to provision, stateless, etc.
Just a compute orchestration is not a complete solution. There are other pieces required to really fulfill that dream, to fulfill that vision.
Yeah, absolutely. You're right that the revolution that VMware started with the VM was obviously on the compute side, but the transition to cloud infrastructures, it's not complete until the triad of compute, network, and storage/data is also transformed to behave in this new agile and dynamic way. And when it comes to this transition, compute always leads. Then networking and security functions follow after that. And I would say data is the last one to the party, so to speak, for a good reason. Because as you mentioned, it has the most gravitational pull. It is really the crown jewel of any company's assets, right? It really, in this day and age where everything is digital, the data lake, or whatever you want to call it, like of any company, really represents anything and everything that the company is about. And that assets need to be carefully protected and handled very carefully. And because companies just have tons and tons of data, it is very difficult to be evolving that infrastructure. Just imagine you're flying like a Boeing 747, and as you're flying it, you're trying to kind of make changes to it, right? I mean, you can't kind of swap out the engines like in mid-flight. And obviously, like, this is a folksy sort of metaphor, but I think it really illustrates the challenge of transforming the data. I think it is absolutely the hardest part in order to achieve that complete cloud transformation.
And let's talk about that range of applications that we're seeing in the enterprise. We still have lots of Cloud 1.0, VMware. We're seeing increasingly Cloud 2.0, container-based. The diversity of applications, the spectrum of applications, the spectrum of platforms, the spectrum of orchestration frameworks is only increasing. The complexity is only increasing. What does that mean for your infrastructure, specifically the data infrastructure underneath, to be able to handle that, to be able to serve all of that?
Now, it's interesting that in IT, nothing ever disappears. Whatever you bring in the data center, it just tends to stay there forever, which basically means that the heterogeneity and the diversity of the kinds of applications and workloads that companies need to deal with just increases over time. But because this heterogeneity of application and workloads is increasing, that really makes it very, very difficult to transform like the data infrastructure, because the implication is that the data infrastructure needs to be able to respond to all sorts of different service level requirements from different applications. And let's not forget that the service level requirement for any application is not something that's fixed over time.
That's right.
It's very dynamic. It changes by the hour, by the month, et cetera. And so that means that the data infrastructure needs to become a lot more intelligent to be able to very quickly understand and dynamically provision to the SLAs that are required by this increasingly heterogeneous corpus of applications. That also means that data, in essence, needs to be provided as a service, just like compute is provided as a service through containers, just like networking increasingly is provided as a service through all the software-defined networking innovations. Data also needs to get there in order to complete that transition to cloud infrastructure. And sometimes people talk about the elasticity of cloud infrastructure. Yes, so the data infrastructure needs to be able to respond both to like the SLAs as well as to the throughput, like the scale requirements that different workloads have.
Bogomil, thank you so much. It's been such a pleasure to have you here. Thank you.
Thank you.
Thank you.
So Datera created the industry-standard LIO subsystem to extend the performance of its custom scale-out protocol to a wide variety of host environments.
All the engineers have different experience in the storage, networking, virtualization, and the server technology.
We at Datera believe in decoupling infrastructure and application via the intent-defined management architecture.
I'd sum up our approach on the front end in 2 words: simplicity and consistency. What we did was build our own front-end specific data models, which we then codified into an internal low-level API.
It knows about the hardware, it knows how to manage the hardware, it knows how to configure it, it knows about users, it knows about the accounts, the volumes, how to export them, it does network configuration, and so on.
At Datera, with simplified APIs and by abstracting application requirements behind the templates, we have built a common interface that can seamlessly plug all of our drivers to these ecosystems.
It is responsible for making sure that you can always retrieve your data correctly anytime you actually need it.
As we talked about, Datera is a symmetric scale-out system built on the aggregation of independent x86 servers. The system is built on multi-generational, heterogeneous nodes, be it all-flash or hybrid. The system is highly resilient with no single point of failure, with an automated mesh data rebuild on media or node failure. The system is built to house multiple applications concurrently with QoS controls to address noisy neighbor problem, as well as effective performance management on a per volume or a per application basis. It provides a rich set of data services, including zero overhead snapshots and clones, a lockless 2-phase commit protocol to scale, and supports consistent atomic snaps for applications. Bill, can you please show us the scale-out and heterogeneous nature of Datera?
Sure, happy to, Ashok. Thank you. So I'm going to walk you through the Datera web user interface today. We've designed a very simple interface that quickly allows you to get the status on the main page. When we talk about the various aspects of Datera, what's very important is be able to have mix and match nodes, to be able to have a heterogeneous cluster. You can see right in the upper left-hand corner, we have both hybrid and flash capacities listed. I'm going to jump down to the storage node page. Here we have a list of the storage nodes that are comprising this Datera system. As you can tell, within this one infrastructure, we have both all-flash and hybrid systems. Each of these data nodes brings capacity, performance, and capabilities to the system with a status marked on the right-hand side. So now I'm going to talk a little bit about the way we do enterprise data protection. So here as a backdrop, I'm going to use a MySQL or MS SQL deployment based on the Datera system. So first, we're able to encode a granular protection strategy using our high-performance snapshots. 15 minutes, 1 hour, 1 day, and 1 week for a total of 1 month of data protection for this application. Second, you'll notice that there are 3 tabs at the top here. These correspond to the volumes that will comprise this application. When we deploy it, we can orchestrate our application to use the data volumes and the log volumes appropriately. What's special about the Datera system is that these storage access points can be distributed amongst any of the storage nodes in the infrastructure, and with our overall snapshot policy, can be atomically snapped at the same time. So as your infrastructure grows, as you add more storage nodes to the infrastructure, we can ensure that data consistency across the board. Next, I want to step over to the vSphere web client to show the Datera integration with the vSphere web client. What we're going to do here is just simply provision the Datera through this interface. So I'm going to use the Datera plugin and select Create Data Store. This is going to bring up a dialog that helps us enter the information for vSphere. So I'm going to call it VMware Data Store. I'm going to choose Advanced Configuration. Here, if we enable our QoS, or Quality of Service Controls, you can see that not only do we offer IOPS capability, but we also offer bandwidth capability. So I can go ahead and set the bandwidth here to say 800 megabytes per second for this particular data store. We can also, from this interface, orchestrate the snapshots. Go ahead and press the Create button, and back to you, Ashok.
What about for large clouds where they have multiple vSphere instances built?
So in a large cloud built on VMware, vCloud Realize is the technology that's most employed, and we fully are integrated with that technology. Thank you.
Great.
Now let's go to Mark for his discussion.
Thank you so much, Bill and Ashok, for this fantastic enterprise application demo. Now I'd like to introduce our next guest, Florian Leibert, CEO, co-founder of Mesosphere. It's so great to have you here today, Flo.
Thank you for having me.
Thank you. I can't help myself, of course, to point out you are a fellow German. Perhaps tell me a little bit about your history and what brought you here.
Yeah, of course. So I got to San Francisco about 8 years ago, and I came here and originally worked at Ning, which was a leading social network at the time. And later on, I actually moved over to Twitter and worked on data infrastructure, so very related to what you're doing now and what our company is, of course, doing.
Yes.
And after Twitter, I actually joined Airbnb, where I worked on similar products, the data infrastructure products. I saw a lot of commonalities of the problems we're trying to solve, both at Ning, well, actually at all 3 companies, Ning, Twitter, and Airbnb. And we're trying to commercialize those efforts now, which we open sourced back in the day.
Right.
With Mesosphere now.
Okay. So let's talk a little bit more about that, because that's obviously a fascinating area that's both near and dear to our hearts. What were the challenges that you were trying to solve?
So what we had to do is we had to take this application that had been built over the years in a very agile way as a monolithic Ruby on Rails application, and we had to split it up into, I think nowadays it's called microservices. Back then we still called it a service-oriented architecture. And so we took out components and we had to deploy these components, right? And that ranged across all types of applications: data services, recommendation, machine learning, and data pipelines. And we had to deploy these services, and that was really difficult. It was a lot of stress for our ops team, because they had to deal with a ton of applications, a ton of different hardware specs, a ton of different software specs. And yeah, it just overwhelmed the ops team. So what we wanted to create back then at Twitter was a self-serve cloud for all developers, so that developers could just go online or onto our intranet and essentially request resources to deploy the applications they needed to deploy. And that's what we did. And we used Apache Mesos, which now is the foundation of DCOS, which is what Mesosphere is building, and which is the product that we're both integrating with Datera now in order to drive modern data lakes and modern data applications.
You went from stateless to more stateful, still container-based applications. Now you sort of had both on the same data infrastructure. Of course, stateful puts a lot more pressure on the data infrastructure itself. You kind of saw applications evolve to services and consume the data as services. So what kind of implications does that have to the data structure, infrastructure itself? How would you ideally see them absorbing application intent, so to speak, and sort of deliver just the data that they need, whenever they need it, at any scale?
So I think, for anything that involves data, latency is a real concern, right? So I think you have to do whatever really reduces latency, and with transactional applications, it's even more important. But and by the way, that's I think a big reason why the world is moving towards containers, because you don't have the hypervisor and the data path anymore, and the hypervisor. Regardless of how much optimization you do, the hypervisor introduces latency. Absolutely. And that's why now what we can do in multi-tenant environments, we can run multi-tenant environments while at the same time reducing latency, and that's super exciting. I don't think that was possible really before the containerization, before containers were part of the solution.
That's obviously matches what you do on the orchestration, on the application orchestration. It matches very nicely what we do on the data orchestration side. We have a multi-tenant platform. We are obsessing about latency slightly. And now, of course, today is a big day because we're actually announcing a partnership between Mesosphere and Datera. We've done a pretty deep technology integration. Let me ask you from your perspective a little bit, how do you look at this? What kind of benefit do you see out of that?
What we really want to do is we want to help solve real problems for our customers, right? And a lot of them are trying to run these large data lake environments, and together with Datera, we can deliver a full solution to our customers, not just a piece of technology, but a bundled solution.
And you guys can then, when you say look at data lake or real-time data lake, that's even more, right? We're going from batch Hadoop-style processing now to a Spark, to a Kafka, to real-time interactive, right? To fast data, exactly. And so that really goes right back to you need to deliver the infrastructure underneath, the data infrastructure underneath fast as well, at any scale.
Yeah, exactly. And so I think Datera is the company that's really leading this space right now.
So Flo, that's fantastic. In your mind, with containers, we're at Cloud 2.0, people are talking about Cloud 3.0 now, fast data you mentioned, massive orchestration. Where's this all going? What's your vision for the future here?
Yeah, so I think my vision is really closely aligned to what we're trying to accomplish at Mesosphere. What we want to create is an open layer that sits above all of the clouds, that allows you to run all of your workloads without you actually having to think about the underlying infrastructure. And that's very different than what is offered today on, let's say, Amazon Web Services, because there you're tied to a proprietary API, you're tied to their product release cycles, you're tied to the completeness that they find is enough for their product, right? And you don't have much choice in each of these cloud capabilities. So what we want to create with DCOS and through partnerships like the one we have with Datera is we want to create a set of cloud capabilities, private and hybrid. So you can start in your own data center, and you actually don't necessarily know that you're in your own data center, but you have resources. The resources are priced at a certain level, and you can just burst out into an Azure, into Amazon Web Services, into a soft layer, and run workloads for a certain price there. And you don't have to think anymore about what's the exact cloud API. I think it's really important that there's an abstraction above it, and that as a developer, you're freed from thinking about infrastructure.
So now, of course, that's a little easier for stateless workloads than for stateful workloads. Data has gravity. It is, because of the gravity, it has inertia. It's a little harder to shift it around. What's your vision for not only stateless, but perhaps also the stateful parts of the containers, let's say for IoT, where you actually do need to process massive amounts of data?
Yeah, so I think a lot of processing will move to the edge, right? Like I think we see this with with some large turbine manufacturers, for example. They are trying to put the processing onto the edge where they get the data. You can't actually send that much data back to your main main data center. And so I think it's really this idea of software-defined infrastructure becomes even more important, because you want to just be able to spin up a small cluster somewhere, right? And control it the very same way that you're controlling the cloud.
Right.
I think you don't want different interfaces and different APIs everywhere. You want to really have a common substrate that is layered across all of that. And yeah, I mean, shameless plug here. I mean, this is really what we're trying to do at Mesosphere.
Yes. That's great. Yes, that's what you're doing at Mesosphere, and you're focusing on multi-cloud application orchestration. But what about a multi-data cloud? What about actually orchestrating the data across all those clouds so that you can also accommodate stateful workloads, or at least a part that's stateful?
Yeah, I think what we want to do is we want to rely on partners like yourself and other vendors to come up with solutions that allow replication and seamless replication of data, so that you can actually take advantage of the processing capabilities elsewhere, right? So if you're running 2 data centers, you probably want to have your data, in most cases, the important data, replicated across both, right? And I think that should be seamless. As a developer, you don't want to think about how do I get the data from here to there. It should be a seamless experience. And I think a lot is happening. And I mean, you guys are doing a great job at really helping the data space become cloud compatible.
Right. Thank you so much, Flo. It's been such a pleasure to have you over today. Thank you very much.
Thank you.
Thank you. Now talking about Mesosphere and DCOS and data clouds, I'm thrilled to announce our next demo, which is actually an integration of DCOS and Datera. And with that, Bill and Ashok, go have at it.
Thank you, Mark and Flo. Now for the microservices use case. Earlier we talked about scale. With scale comes complexity and the need for control. Datera provides a very simple programmable interface based on RESTful API and a fully self-describing schema. Complete system monitoring is as simple as a single API call. In addition, templates in application instances are used to operationalize the intent-defined storage concept. With these constructs, the Datera system decouples application provisioning from physical infrastructure management. This allows the user to configure the desired state. Mesosphere is a typical example where scale is managed, and Datera templates allow for automation to scale. Datera accelerates multi-user, multi-application, and multi-tenant environments by providing not only resource segmentation, but also network segmentation through IP pools. Bill, can you walk us through a Mesosphere DCOS deployment and storage provisioning, and walk us through the API integration with it?
Sure, happy to. Thank you, Ashok. So here we have our Datera user interface again. What I'm going to do is jump over to the Mesosphere DCOS. The DCOS component of Mesosphere manages the physical infrastructure. For managing long-running containers, you want to use the Marathon service. So I'm going to transition to the services page and launch the Marathon user interface. So the way we can provision storage with the Datera is using the Create Application button. I'm going to jump to what they call the JSON mode and put in a predefined set of commands just to save some typing. If we look at the various questions that are asked here, they want to know the name, the ID, what the system resources look like, and we can configure the environmental variables. You mentioned the Datera templates. These are critical to what makes Datera different from other storage systems. And here you can see we're specifying a template called the dev container. So I'm going to go ahead and create this application. So this is taking a JSON-described application, providing it to the Marathon service to have it deployed along with the DCOS in a container running in this infrastructure. It is going to take a few seconds. It's creating the volume on the back end of the Datera, formatting that volume, and attaching it to our container. So now you can see we have a running container with the Datera back end. I'm going to now jump over to the Datera side and let's see what happened. So I'm going to go to the Provision Instances page, and I'm going to scroll to the bottom here, and you notice that it has a Mesosphere volume, and it has about 300 gigabytes free. You'll notice that when we did the creation, I didn't tell it what size to use. Part of making a DevOps infrastructure is making it invisible to the users. All I knew as a developer to use the dev container. If we examine this, we can see what our provision storage looks like. I'm going to click on Storage 1. We can see we have our access points, our ACLs are put in there. We've got the performance of limited to about 300 IOs per second. We can see which storage nodes it was provisioned from. We can see the type of storage nodes. In this case, it was a hybrid provision. And at the top, you can notice where I have the template itself. And this lists the other instances that are provisioned within the infrastructure based on that same template. So as an application developer, all you need to know is which template, which type of resource you're allowed to consume, and the system can manage it fully for you. Thank you. Back to you, Mark.
Thank you so much, Bill and Ashok, for this fantastic container demo. Now I'd like to introduce the Senior Vice President of Platform Technology from Comcast, Mark Moule.
Thank you, Mark. It's nice to be here.
It's awesome to have you here, Mark. Tell us a little bit what you do at Comcast.
So I'm part of the technology and product group at Comcast. This is the organization that's responsible for building all of the products and services that we sell to consumers and to businesses under the Comcast Business and Xfinity brands.
Now, you've been at Comcast for how long?
9 years.
That's quite some time. I'm sure you've seen it evolve a lot from a business and from a technology perspective.
Very much so. I mean, we've really been focused on the technology side on moving a lot of the intelligence of our experience into the cloud so that we can provide a much richer experience to customers.
So you've been moving a lot of the intelligence into the cloud. What kind of challenges have you faced on that journey?
So it's really put a strain on our data center infrastructure. We've really had to grow significantly to move all of that capability onto systems that are running inside of our data center. Comcast has a public and private cloud strategy where we have some of our technology running inside public cloud providers and some of it in private cloud, in our own internal private cloud. Building that infrastructure in a way that is both scalable and reliable, especially as the numbers of systems grows into the 10,000s and hundreds of thousands, has really become a challenge.
Excellent. And what kind of technologies, what kind of tools are you looking to help you solving those challenges?
So we're looking for ways to run lots of systems at scale, everything from virtual machines with VMware and through KVM and OpenStack to containerization with Mesosphere and Kubernetes.
So you really are looking to run any application in any stack on a kind of unified data cloud that serves all those data needs.
Right. We're at a phase now where we're trying to drive a lot of our infrastructure to more common infrastructure. Typically, in the past, we would build bespoke physical infrastructure for each application. And over the last few years, we've really tried to shift away from that, where the application developers are developing to a platform, to a physical infrastructure platform that's much more consistent.
What does that mean for the data cloud, for the data infrastructure that's underlying all of this?
Well, it really becomes a challenge because building a particular piece of infrastructure for a particular use case is pretty straightforward. You can optimize that infrastructure to handle the workload that you anticipate. But then when you start to layer on different use cases on top of that common infrastructure, it becomes much more challenging because you have a high-performance database that needs really fast I/O, living with a database that's collecting system metrics and doesn't need the I/O performance necessarily, but needs to have access to very efficient, cost-efficient, large volumes of storage so that it can have a long history to look over.
So it sounds like you really need a data infrastructure, a data cloud that molds the infrastructure, orchestrates the data just to precisely fit your application needs, and that can be a large spectrum.
That's exactly right. We want to be able to identify the workload that's happening on top of a given piece of infrastructure, on top of a piece of shared infrastructure, and optimize that workload on that common infrastructure. And the optimization choices that we might make from one application to the next might be very different.
So it sounds like what you really need is policy.
That's exactly right. We need to be able to identify the specific workload that's working on top of this common infrastructure and have the infrastructure respond accordingly to that workload.
And on top of that, not only policy, but policy that can automatically fit multiple tenants and roles that multiple tenants actually can bring to all of this unified infrastructure.
That's exactly right.
Excellent. So we've been working on a pretty exciting demo together. It's basically a real-time IoT data lake, data cloud. It also actually brought Google into the fold on Kubernetes to actually bring this data cloud into microservices, and then we use Datera for the persistent backend. What kind of use cases do you see for an environment like that?
Well, this is really the first of many, I think. It's been a great learning experience for Comcast as we've gotten to know how the container systems work, and we see in that in that technology a great opportunity to really help us scale our developer pipeline all the way out through deployment and version control and upgrade process. And then on the storage end, we want to make sure that whatever storage technology we pick, we can use it for as many different types of workloads and as many different environments as possible. So working with Datera, we found that it was incredibly easy to get it working in the first place on a technology that we were unfamiliar with. And we anticipate being able to scale it up, not just for this IoT workload that we're working on today, but for a lot of our data analytics platform.
Excellent, Mark. That's great. So let me perhaps take a step back and ask you a little bit, what is your vision for the future? Where do you see infrastructure? Where do you see data clouds going in the kind of big picture?
Well, I think that we are in the era of the public-private hybrid cloud. And I sort of think of it as this slider where you'll have a certain amount of public and a certain amount of private, and this will be the mix. We'll be in this world for the foreseeable future. At Comcast, we sort of make the choice on an application basis. Do we want to run this application in public, private, or a mixture of the two, perhaps to achieve better resiliency characteristics and so on? So we're going to be in this world for a while. As far as storage goes, there's always this interesting progression of capabilities. And one of the reasons we're so excited to work with Datera is that we see that roadmap that we're really looking for, moving to a higher degree of sophistication around these capabilities, not just the policy stuff that we were talking about, but things like data replication. Today, we provide a lot of resiliency to our data platforms at the application layer, where the application is sort of handling the geographic resiliency that we need in multiple data centers and different availability zones and so on. And I think we should ask ourselves occasionally, is that where we want that intelligence? Or do we want to push some of those responsibilities deeper into the infrastructure layer so that the storage subsystem comes up with those capabilities for us? And the applications running on top of it just get to use it.
So it sounds like you're looking for data infrastructure that just molds itself, that orchestrates the data just to precisely fit the needs of your applications.
Just like we want to be able to orchestrate the applications, we want to be able to orchestrate the infrastructure underneath it.
Excellent. And then on top of that, of course, once you have your applications encapsulated in policies that are inherently invariant and portable, you can move them around as you please.
Exactly, within our own private cloud and to the public cloud.
Thank you very much, Mark. It's been such a pleasure to have you here.
It's been great. Thank you, Mark.
Thank you, Mark. Thank you. And since we've been talking about data clouds, let me pass it back to Bill, who will actually show us a little bit in that department.
Thank you, gentlemen. Moving on to the data cloud use case. Data clouds need service delivery velocity, the need to change performance, the need to rebalance, and the need to efficiently share data. Most big data and analytic applications need cross-sectional I/O bandwidth more than IOPS. The Datera QoS bandwidth controls come in handy here. With the ability to promote or demote volumes between multiple media tiers, between all-flash or hybrid, between single replica or all-flash replicas, and live change of QoS parameters, Datera allows for optimizing appropriate data pipelines. In addition, the ability to clone snapshots and instantaneously mount for access makes it easy for multi-reader applications to get the performance while saving on capacity. Bill, it's time to pull together a data analytics use case. And can you talk about the flexibility as well as the dynamic behavior of the system?
Absolutely. Thank you, Ashok. So what we're going to show today is the Datera system orchestrating a microservices-based analytics environment. The actual infrastructure code was provided by our friends at Comcast as an open source project that integrates Yarn and Spark within a microservices framework so that you can quickly spin up analytic environments. What we have here and what you're looking at is the Datera on the left-hand side and the initial deployment on the right-hand side. You'll notice that the current number of data nodes is equal to 1. What I'm going to do is using this framework, again, the open source framework that orchestrates the microservices infrastructure, we're going to ask it to, instead of have 1 node, to make it a total of 5 instances. So in the background, what this is going to do for us is automatically spin up, mount, and join into the HDFS environment 4 additional data nodes. Now, what's important here is that within the HDFS environment, you can manage multi-tenancy through tools such as VMware or OpenStack, which is how our friends at Comcast do it. So I'm going to go ahead and refresh the data node page, and you can see we already have 2 of these containers spun up and ready, joining into the infrastructure. You'll notice now on the Datera side, it's automatically updated our instance count from 49 to 53. So we have our new volumes created, they're provisioned. I'll refresh the Hadoop side one more time, and now you can see we have a total of 5 data nodes executing a single command. It makes the velocity of doing analytics environments much, much faster. Ashok?
Bill, can you show us an example of promotion or demotion of a volume between media tiers?
Absolutely. So what I'm going to do here is show the Datera template system. So normally in a normal system, if you want to make a change to an existing volume or provisioned storage, you need to do each volume at a time. So here we're going to actually use the Datera template. I'm going to scroll down to the HDFS data node template. You'll notice here that we have about 6 provisioned instances. And I'm going to edit the configuration, the policy for those instances. At the moment, you can see it's set for a hybrid storage node. We're going to hit the edit button in the corner, scroll down, and there's actually 3 placement policies presented. We have the all-flash replica, which is what we're trying to do now. We also have this concept of a 1 replica flash, and it's something that's relatively innovative for Datera. What we can do is when we're provisioning the targeted placement of these applications, we can route all the data set to 1 flash node and the replica copies to hybrid nodes. The main benefit of doing this is for economics. So now you have 1 copy of flash, 2 copies of hybrid, and the system can manage that. So I'm going to go ahead and press the save button here. And now in the background, the Datera system will orchestrate and manage the data placement, move the data from the hybrid systems to the all-flash systems.
That was simple. Great job, Bill.
Thank you.
Thank you, everyone.
Ladies and gentlemen, please welcome back the CEO and founder of Datera, Mr. Marc Fleischmann.
What an incredible day. Thank you for joining us all today. Thank you for joining us over the telecast. I look forward to the sessions afterwards. Join us in the data era with Datera.